So next, I'd like to introduce our second speaker, Dr. Ben Gratus, who's a genomics solutions expert at NRG in Israel. So Ben has been working in the biotech computational biology industry for the last 10 years. And before joining NRG, he was working at Evogene for over 8 years in both research and business development positions. Ben has led all aspects of innovative computational platform development, including market assessment, scientific design, platform design, execution and management, and in vitro validations. So I'd like to hand the time now to Dr. Ben.
Oh, hi everybody. I'll share my screen. While I do that, I want to thank the organizer for inviting me for this very nice panel. It's very nice to hear all of these presentations. One second. Okay, is it in slide in presentation mode?
Yes, it is. Thank you.
Okay, so once again, hi, my name is Ben. I'm from Energene. I'm a genomics solution specialist, and Energene. I'm not going to speak about a specific species. Energene is a company that in general help optimize variety development and production through genomic AI solutions. So we were founded in 2010. We went in IPO like 2 months ago in Tel Aviv Stock Exchange, raised around $30 million. And our first product was launched in 2015. We are active worldwide. We have centers in the US, in Canada, in Israel, and in Europe. We completed hundreds of projects with many customers working on different species. Some of them, of course, are aquaculture species. We published many peer-reviewed, so our technology can be viewed and were reviewed by many experts in the world. Yeah. So this is just a slide showing our activity. We are active in different industrial segments. Our main business is in the seeds and agrochemical world, where we collaborate with the big seed companies like BASF and Syngenta, but we also have activity in the natural raw material, food and beverages, and cannabis and hemp industries. And the common thing for all of these is that we help improve varieties. Varieties of the big seed companies like maize and soybean, varieties for natural raw producers like Bridgestone, who produce rubber from plants, food and beverages, where we collaborate with Enzutic for development of advanced freshwater prawns, and also in the cannabis industry for development of advanced varieties there. So our technology can help improve any kind of species, and has been shown in the last couple of years. So what do we actually offer? So we have an holistic solution for molecular breeding. Molecular breeding is developed in the last 2 decades into a level that it can help improve variety development and reduce the cost of development by 50% and increase time to market of production. On one of the recent panel presentation, Dr. Jiang shared with us the development of the CBAS, and the time it took. It was almost over a decade to reach the current stage. We believe that with advanced molecular breeding, we can reduce this time by half. And this is one of the things that has been advanced in the plant world, and the aquaculture world is I think it's the youngest industry in agriculture compared with animal breeding and plant breeding. And I think that the opportunity to advance and generate new species is immense. It's like the diversity that exists. It's amazing. We at Energene look at this as great potential to generate and improve existing and new species using our AI technology. So I will just go fast on our technology and what we can do and accomplish. So this is our holistic solution. It's called GenoMagic as a whole. It's a breeding platform that helps breeders take decisions in which who to cross and which progeny to select, so it will be the representative for the next generation, and so it composes of different steps and levels. So in the base of it, you have the reference genome. And the reference genome is like the anchor in which we tie all the information coming from a given species in the GenoMagic platform. We think that Energene first product was a pipeline for de novo assembly, considered the gold standard in the world. We were the first to assemble the width and genome, and that's in the plant world. We were also the first to assemble the first female genome of the freshwater shrimp, which allow us to do a better diversity analysis on breeding population in order to choose which one we want to use within our breeding program. So reference genome is something which is very complex, and Energene's technology can do it better than other solutions available in the market. We can, and the main problem with animal genomes and of course fish within is that they are heterozygote compared to homozygote genomes that are usually found in the plant world. And Energene technology can actually assemble the genome by separating between the two haplotypes, meaning seeing all the resolution of the different alleles that are available, and we don't generate one genome which is like a compression of the two different parental lines. So this is one of the projects we did. We did several projects. For example, we assembled the rainbow trout. We also work in the shrimp world, also in gray mullet and other fish. Our technology proven ourselves. We have several publications showing it, and this is the basis for our technology. So once you have a reference genome, the next thing you want to do is check for the diversity available in your breeding population or in other breeding materials that you want to check whether it is good for your needs and purposes. So we do that by we take our diversity tool, and we can do a relatively low coverage sequencing, compare it with the reference genome, and develop tools that will help you choose the relative the individuals that you want to get to be part of your breeding population. Based on the diversity analysis, we can then develop a genotyping solution in which is a cheap and easy way in order to check progeny and new candidates for breeding, check the genomic for any kind of markers for resistance, or even more complex traits like FCR or tail or filler weight or whatever is in your interest. Using this genotyping, we can then help in develop prediction models, starting with identification of markers for resistance, for disease, and more advanced tools like genomic selection or GWAS that can help you accelerate the advancement of your breeding program in order to reach the marker much sooner than before. I think that if we look in general at the aquaculture world, I think that the salmon in Norway is also, that everybody knows, is a good example on the way that how they reduced the FCR over time. And we believe that with many other species that are currently focusing, like tilapia, like Bermundi, like sea bass, and the opportunity to reduce these kinds of traits using molecular breeding is something can be quite valuable in order to advance new varieties with these kinds of advanced traits. So this is just some of the examples of the potential projects that can use energy and technology. Some of these projects are already on the way. So we can take our technology and we can assess genome and choose for non-allergenic plants, non-allergenic wheat. We can breed tomatoes for resistance to destructive virus. We recently discovered a resistance line for one of the main currently virus that is threatening the tomato technology, the Obama virus, the brown robust virus. We can breed for improved food conversion rate and tail weight and other quantitative traits in aquaculture using the development of different molecular biology tools. I can say to you that last week we just signed an extension agreement with Enzutic for the development of these exact tools in order to help with the breeding process to make it more advanced and introduce new material to the market. Another way that we can help is by introgressing of traits from wild varieties. When breeding programs are being advanced, then you can get your low FCR variety, and suddenly there is a new disease that is threatening the breeding population, and you know about a wild variety which is resistant to the disease. Using molecular tools allow you to introgress that trait into your breeding population without losing all of the advanced traits that you worked so hard for to breed in many years. So introgression of traits from wild varieties is something that we can see. We can think of introgression of traits like resistant traits, of quality traits like color and resistance to different conditions like cold resistance. This is something that we see in Israel in the tilapia, that in winter times the growth rate reduced significantly, and we are currently trying to work on a solution to increase growth rate in colder climates, in open ponds. We can also breed for a longer shelf life for tomatoes. This is something we collaborate with companies, and for other qualitative traits like taste and texture for the legumes to fit the alternative protein market that is currently being developed. Our solution can be optimized for each company regarding on their needs, on the availability of genetic material. So these are just a few examples of potential things that we can achieve using our artificial intelligence technology. So to summarize, our value proposition is that we can help reduce R&D and development time and make it more efficient. Doing that, we can actually directly reduce the R&D cost. We can implement the use of big data in the decision-making process of breeders and organizations. We are relying on our partner. We are partnering with Amazon, with AWS, in order to have our data management, so we can be kind of a outsourcing of genomic analytics and data management cloud for any partner for the generation of interesting projects in the aquaculture industry. Thank you. This is my contact. If you have any question regarding anything, I love to talk. I love to talk with new people and hear about new projects. I think that's one of the main things that is interesting about my job, that I can work one day on poultry and the next day on fish. Yeah, so thank you very much for this opportunity.
Thank you, Dr. Ben. Sorry, just before you go, there's this quick query from the audience. They just want to confirm that, do you alter the gene structure, or are you just helping select the best, pairs to then mate and crossbreed?
Well, currently we are a non-GMO solution, meaning that we are not going to alter the genetic of fish, of any species. We are part of a consortium dealing with CRISPR technology. We can offer a solution for people who use CRISPR. We are not performing it ourselves. We see that there might be a great value in this technology. We know that the main thing about this technology is understanding the genomes. The high resolution genomes can help you identify the exact nucleotides that you want to change. But currently, most of the things that all of the things that I presented today, our holistic genome magic solution is based on using advanced AI genomics into increased traditional breeding and transform it into advanced molecular breeding.
Thank you very much. Thanks, Ben. All right, to now invite all three panelists back. I think we have about maybe 5 to 10 minutes for a quick Q&A and discussion. Over the last, I think, 10 to 15 minutes, we have really seen three very innovative and novel ways, right, that we can meet the rising demand for protein. So now's the time for the audience. If you have any questions, to please type your questions into the Q&A. I know there are a lot of questions on genetic editing and some of the more ethical questions. However, I would like to say that for your GMO questions, let's keep that for the next webinar. So if you want to find out more, you have to join us for the next webinar. For today, we'll be focusing specifically on selective breeding, right? So these are non-genetically modified species. Or let's just keep the discussion around that so that we can segregate our sessions a little bit more. Okay, I think the first question I have for all panelists, and I just want to hear your thoughts on this, is, there's a lot of farms that are coming out now, and do you agree with the statement that we do not need to farm more fish, but we need to farm better fish? Do you think there's enough now, or do we still need to constantly increase our production? Alex, what are your thoughts on this, Alex?
Well, I think, of course, the supply part of the value chain is reacting to demand. So if we don't want to produce more, we need to, humans need to eat less protein, put it that way. So for as long as that is in place, and I think that will continue to be in place, a higher demand for animal proteins, I think fish production and fish demand will continue to grow. I think the opportunity here versus other forms of protein is that aquatic protein is well done, and it's a very efficient way of producing protein in a scenario of resource scarcity. So yes, that's my...
I think they go hand with hand, because one thing I think on one of the last earlier presentation that people talked about local food, I think it was Dr. Jiang, about so with aquaculture, when you go and growing on land, you can actually grow near the customer. This is something you can see also with vertical farming in the plant industry, and this is correct for fishes also, and for aquaculture also, and I'm sure that Alvarez would like to send his tilapia fingerlings to everywhere in the world. So every large city we have like a small plant to generate fresh fish for everybody. So you do want to have a more advanced technology and continue keep growing on different parts, on different areas. But you will need better fish for doing that. You will need fish that can actually grow in different climates, that can grow in different conditions. Aquaculture wasn't born to be raised in a fish tank. They were born to be raised in the sea or in the river or whatever you are. And so natural selection, natural breeding can help you actually improve so they can do better in those environments. So they do better in different climate conditions. So they do better with growth rates, so they can actually supply all the need of a close community that they are being grown next to. So it goes hand with hand. And I'm all for local. I believe in local food. I believe that we need to reduce greenhouse transmission by transportation of food all over the world, and genetics can give us the tool to do that in land farming of aquaculture.
Thank you. Okay, the next question I have is for Dr. Diana Chan. In light of food security for Singapore, how important do you think it is that we have a local production of our own? For example, you're doing a hatchery, right? But as compared to Alex's company, Alex sends fingerlings to different countries. But in, let's say, in like a food security angle, how important do you think that we must keep it within the country? And then after that, Alex can reply after Dr. Diana has said her piece.
Well, in the first place, I think that we import a lot of our food, right, from other countries, at least about 95%. So we are very much reliant on the import. So to be self-sufficient, at least, you know, by a certain percentage, it is actually important to actually grow the fish ourselves. And as such, hatcheries are very important because right now there are very few hatcheries. And a lot of the farmers, they import the fries from overseas and they are having some problem with it because when they actually arrive at the farm, the survival rate is very low. So I think hatcheries would be the way to go. I think especially for finfish, if you want to meet the needs of the local consumption to at least be more self-reliant and for food security reasons, we should be actually going into the fish hatchery locally.
Alex, do you have any views on this? Do you think it's, like for food security reasons, do you think it's better to do it in country, or is it better for your company to do it in a, let's say, a regional headquarters before shipping out fingerlings?
No, we actually, what we ship is parent stock. We ship the parents, the fathers and the mothers of the production fish, and we fully agree on that the production of seeds needs to be close to the market. Moving fingerlings, in this case tilapia, it's very expensive. It's actually anti-economical moving them by air. So no, we make investments in the countries of production that has the scale to make a business out of that. So, and what we ship again is parent stock, and then it's just very few animals that you need to ship around. Yeah.
All right, thank you very much. In the interest of time, we'll have to end the Q&A session here. There are some questions that are directed to each of you in the Q&A tab, so feel free to answer those questions when you have time. You can just type your answers to some of the participants. All right, thank you. Thank you all very much.